Hello and welcome to Education at SSBJ online video tutorials. We are with a fresh chapter, Sound, of class 8th CBSE. Ear and brain together gives a kind of sensation, what is called sound. When we look around, we hear many types of sound. Bell sound, human speaking, car horn, sound of aeroplane, chirping of birds, and so many. What is sound then? How does it produce? Sound is a form of energy. Like any other energy, such as heat energy, light energy, sound is also a form of energy. But how does sound produce? Sound produce out of vibration. What does vibration mean? In simple terms, vibration mean to and fro motion. When we speak, our vocal cord vibrates, and so as vocal cords of other living beings. Machines vibrate to produce sound. So what we have learnt till now is that sound is form of energy and sound is produced because of vibration, right? But wait a minute. In this illustration, there is to and fro motion is on. That means vibration is on. Where is the sound then? To understand this, we need to know the meaning of loudness, time period, frequency of the vibration. To understand what is time period and frequency of a vibration, let us visit Science Park. So here what you see in front of you is your school science park, and we have got a model of a simple pendulum there, and we are going there. Right. Before that, let me tell you what is simple pendulum. Simple pendulum is just a weight which is tied to a string, and that string has a rigid support. There is a heavy breeze here, you can see all around, and now here we are in front of a simple pendulum. As I have told you, simple pendulum is a weight which is tied to a string, and one end of the string is fixed there, right? So once you give a force on this, it starts to and fro motion, and to and fro motion is vibratory motion or oscillatory motion. What we have learned so far is sound is because of vibration. Now in front of you a ball is vibrating, a weight is vibrating, to and fro it is moving, and we are not hearing any sound because of this, right? And here we have to find the answer why it is so. But before that, again let me tell you, simple pendulum is a weight which is tied to a string and fixed to a rigid support. And let me now going to explain what does a one vibration mean. What does one vibration mean, or what does one oscillation mean? Right. Now, this position of the simple pendulum is the initial position. Remember this, what is this position? Initial position. Now when you start moving, how to move? You have to apply force, and it goes on either side to extreme positions. It's going on either side to extreme positions, right? So from initial position to extreme position. Now focus on this. From initial position to one side extreme position and to another side extreme position and coming back here is one vibration. Again, from initial position to one side extreme position to another side extreme position and coming back to initial position is called one vibration or one oscillation. Otherwise, the best way to have a oscillation, you start from here. Okay, you start from here and then it goes and comes back. So one vibration is over, second vibration is over, and third vibration is over. In this way you can count the number of vibration. Otherwise it is very difficult to look at the initial position and count. Did you understand? Now what else is left? We are left with meaning of time period and frequency. Right? Let me tell you. Time taken, how much of time it takes to go from this end, that is one extreme position, go there and comes back. How much of time it takes? It is called time period. Right? So time taken for one vibration, time taken for one vibration or one oscillation is called time period. Now what is frequency then? How many such vibrations will be there in 1 second is called frequency. We shall go in detail now. Sound is form of energy. Just like there are many other forms of energy, such as heat energy and light energy. We have also learned that sound is produced because of vibration, right? It is the vibration which makes us to hear sound. But what is vibration? Vibration is to and fro motion. The best example for this to and fro motion is simple pendulum. Simple pendulum is a metal bob. I repeat, it's a metal bob, B-O-B is the spelling, which is tied to a string, and then one end of the string is tied to a fixed support. You must have seen this example in swings. So this is what to and fro motion. Now let me stop this simple pendulum, go frame by frame and try to learn the motion involved in this simple pendulum. When simple pendulum initially was at rest, this position is called initial position or mean position. But then we have to give a force on it. We have to pull it at one side and support it to acquire some energy. Now when we pull it on one side, it is going to a particular height. It receives a kind of energy which is called potential energy, right? And now the position of this simple pendulum is called extreme position, right? Remember this extreme position, because we require these positions to define a particular concept. So one side we have reached extreme position, and then we have left that. The moment we leave this metal bob, the gravitation force of earth will start pulling it downward, but it is tied to a string, right? So it will come back to its initial position, or we can say mean position. Well, will it stop there? No. It will continue to move. It has that energy, or we call it as a momentum, which we will in detail study in higher classes. So because of that momentum, it is still pushed on other side, and it reaches a particular position there. But when it reaches that position, will it stop there? No, it doesn't stop there. Now what is this position called? Remember, it is again an extreme position. So we have on either side extreme position and the initial position, okay, and it comes back to initial position. So this is how the movement takes place, right? And pendulum swings. Suppose if this pendulum is placed in vacuum, I think it will swing forever. Do you know why? Because there is no air inside. And since there is no air inside, there is no friction. So if you keep this pendulum in air or in a room where air is there, so slowly it will come to a halt, but it takes some time. Why? Friction force acts always opposite to the direction. Right. Now at this position, you have learned how a pendulum swings and what are the different sequences of the pendulum, such as mean position and two extreme positions. Now we'll come back to the meaning of what is one vibration or one oscillation. So one oscillation means a movement of a pendulum from its mean position to one extreme position, and then from that extreme position again back to mean position and goes to another extreme position, and then come back to a mean position. The movement of a pendulum bob from its mean position to both the extreme positions and back to its initial position is called one vibration. I am going to repeat this. So one vibration as well as one oscillations, both are same in this case. Now it starts with initial position, that's a mean position, and then goes to one extreme position and then swings back and goes to another extreme position and coming back its original position. This is what is called one vibration or one oscillation. It can also be equal to, one vibration can also be equal to, if you start your swing from one extreme position, right, and then it goes to another extreme position and comes back to the same position. This is also a one vibration or one oscillation. So if you consider the second method, it is very easy to measure the time. Now wait a minute, why should we measure the time? And what is that time called? The time taken to complete one vibration or one oscillation is called time period of the vibrating body. That means you leave from one extreme position, it goes to another extreme position and comes back to the same extreme position. How much time it has taken, that is a time period. For example, here is a pendulum arrangement at its extreme position. We start with extreme position. And we have a clock with us. And it's a countdown timer. And it starts countdown of time. So you have to watch this properly and tell me the meaning of time period. We shall start now, and countdown started. It goes to one extreme position and comes back, and we have to stop this clock now. Right. Now you see, we had one vibration or one oscillation and we have the time there. And how much is the time? Time taken is 7 seconds. Well, in this illustration, time period to complete one vibration is 7 seconds, right? And I repeat, what is time period? Time taken to complete one vibration or one oscillation. Right? So we can straightway right here, time period of this pendulum is how much? 7 seconds. So remember the unit. SI unit of time period is SI unit of time itself, standard unit. And what's the SI unit of time? Seconds. So time period also will be in seconds, simple one. But wait a minute. If 7 seconds required for one vibration, if 7 seconds required for one vibration from one extreme position back to the same place, how many such vibrations will be over in 1 second? Just think. The question is, if 7 seconds required for one vibration, then in 1 second, how many vibrations? So we can, it's a simple math. So 7 seconds gives us one vibration. And 1 second will be simple, 1 by 7. 1 by 7 what? Vibrations per second. Right? Remember this unit. 1 by 7 vibrations per second. So we have found how many vibrations takes place in 1 second as far as this pendulum is concerned. Can you tell me, what do you call the number of vibrations per second? Number of vibrations per second is called frequency. So what is the frequency of this pendulum? 1 by 7 vibrations per second. But wait a minute, I have written hertz there. What does it mean? Vibrations per second is named as hertz. Vibrations per second or oscillations per second or cycles per second, all that is called by hertz. So 1 by 7 hertz is nothing but 1 by 7 vibrations per second. So that is the SI unit of frequency. So what is frequency? Number of vibrations in 1 second is called frequency. And why is the name hertz? Again, vibrations per second or cycles per second or oscillations per second is called hertz, just to give respect to a German physicist, Heinrich Rudolf Hertz, who worked in the field of electromagnetic radiations, electromagnetism, and many other fields. He has studied more of waves, right? So therefore, the name Hertz given. What we have learnt in this video tutorial is meaning of time period, that is time taken for one vibration, and then we have studied meaning of frequency. So frequency is number of vibrations in 1 second, and the SI unit of time period is second, and SI unit of frequency is hertz. And what does hertz means? Hertz means vibrations per second only, or oscillations per second, or cycles per second. So we'll end this video. In the next video, we'll take up again few more calculations of time period and frequency. Till then, stay healthy and stay fit. Thank you.